Seems like it's recording.
Yep. And here come the attendees. Recognize some names in there. Hi, everyone. Thanks for joining. We're just still having a lot of people joining, so we'll give it a little bit more time. Great. All right. The number is balanced, but I'm just going to give it a little bit more time. And it looks like we have just one phone-in caller, so that's good. All right, so the numbers have I think most everyone has joined, so we can go ahead and get started. Jessica, if you want to give the introduction and kick us off here.
Sure, just making sure I'm off mute. All right. Well, thanks everyone for joining us this evening. We've prepared a roughly 15-minute presentation. We want to make sure that we allow enough time for Q&A after that, but we have put everyone on mute just to prevent interruptions during the presentation. But while we are presenting, please feel free to type your comments by hitting the Q&A button on the bottom. And you can go ahead and enter those, and then we'll answer these questions once the presentation concludes. At the end, though, there will also be another option to ask questions live. Also, we are recording this webinar, and we'll send this out to all registrants after the meeting for reference. But without further ado, I'd like to introduce Dan Harms, LPEA's VP of Grid Solutions, who will give part of the presentation, and Dominic May. He's LPEA's Energy Resource Program Architect, and he will also be presenting. So go ahead, Dan.
All right. Dominic, if you can cue up the presentation. And everybody, welcome to this Earth Day presentation that we have for you. We're excited to be here with you and sharing some what we think is very exciting information. And hopefully you find something that you can walk away with and encouraged and have some good takeaways from this as well. Today's topic is going to be on beneficial electrification. And, it's a term that we use here at La Plata Electric pretty frequently, but we realize that's not a term everybody and all of you might be familiar with. But basically that means that we're looking to responsibly electrify many things, maybe even everything. And I think the responsibly is a key word to that, and we're going to go over what that definition of beneficial electrification means here in just a little bit, and so we'll fill you in on that here more shortly. Dominic, could you click on the next one there? All right. First, a little background on La Plata Electric, founded in 1939, delivering power to our members all across La Plata and Archuleta County. We have a board that has 12 elected officials to it. You get to decide who is on our board. And La Plata Electric, I'll round back around to that first one. We are a cooperative. That means we're owned by you. We don't pay profits to our investors. We pay our capital credits back to you, our members. We are the 5th largest co-op of 22 in the state of Colorado. And, we've been in the news a lot lately on power supply items as well. And so we currently buy 95% of our power from Tri-State. We source 5% of that locally. We're certainly pursuing lots of options to ensure that we're giving our members the greenest and the best value for their electricity purchases that we possibly can by exploring all the options we're looking at there. Okay, Dominic? So in 2019, we established a new strategic goal for La Plata Electric, and that was to reduce our carbon footprint by 50% from 2018 levels. It's a pretty big goal that we set for ourselves and to accomplish that by the year 2030. And I think the key aspect of that is that we're doing this while holding rates where they are and keeping our our competitive advantage relative to the other electric cooperatives in Colorado. And that's the second part of the goal, which is to keep lower than 70% of our cooperative peers, which is where we have historically been. So we want to maintain that competitive nature there. Go ahead, Dominic. And so now on to the beneficial electrification aspects. I'm going to talk a little bit here just on some of the generalities of it, and then Dominic is going to go into each one of the technologies and talk to you about some of that thing. And we'll take, like I said, those questions at the end of the presentation here. So for beneficial electrification, there's really three key elements that really fit this definition here. And it's the aspect, it's the thought of using electricity over other fossil fuel over other fossil fuels such as propane or gas to do that same work. The key things are that it needs to save you money while we're making that transition, that it also benefits the environment by reducing greenhouse gas emissions, and it makes a more robust and resilient grid. And really call it beneficial electrification. It needs to meet at least one of these items without impacting the other two that are left. And so we're really thinking that a lot of the beneficial electrification efforts can actually hit all three of these things. And that's some of the stuff we'll be touching on here. Dominic, go ahead and slide one more there. And so these are some of the technologies we'll be hitting on today. And today we're going to give you sort of that high level view of a lot of this stuff. And I think in future presentations that we give to the public, we're going to take deeper dives into each one of these. And so look forward to seeing more of this kind of information coming to you in the future. But today is just sort of that introductory part of it to get you a familiarity of all the different things that are out there. And some of you may be familiar with heat pumps, some may not. Dominic will be covering what those mean to you here in a little bit. I know a lot of our members are also familiar with our electric thermal storage, ETS heaters. Over 2,000 of our members use that as a source of heat for their home. But there's new outdoor all-electric equipment, of course, electric vehicles on the horizon, induction cooktops, e-bikes. There are lots of things that are sitting out there. And you know, we hit on the emissions part of that real briefly, that the grid is getting greener and greener every day. And with our goal that's ahead of us, we anticipate having a very green grid that allows us to use these technologies in an environmentally friendly manner. So Dominic, you can correct where I went wrong and take it from here.
That sounds pretty much right to me, but yeah, so as Dan mentioned, this is probably going to be kind of old hat to some people, and I apologize if it's reiterative, but I will kind of talk at the high level about each of these technologies. And all of these, I would also reiterate, are available. Beneficial electrification has myriad different things under the umbrella, and everything we're going to talk about here, you could go out and do in our territory tomorrow, basically. So the first one we're going to talk about are these heat pumps, and I'm not just going to read the slide to you, but tell you a little bit about heat pump, which, as Dan mentioned, probably some of you do know what that refers to. But I think the simplest way you can really think of it is if you're familiar with like a can of beer or bubbly water and you open it up and it gets colder, it's stealing the heat from the metal and the air around it as that compressed gas exits and needs to take the heat with it as it expands. So if you kind of imagine you've got a compressor refilling that constantly, that's a heat pump basically. And in this case, they work both as air conditioning and as heating by reversing the flow on them. And ductless versions are another big thing it mentions on here, but you basically don't have to put in new ducting, you can drill really small holes. And so for these mini splits, people have been doing supplemental heating or AC, and they work really well for that. And as you can see, we've got a pretty good rebate on those. And the same principle applies to the heat pump water heaters. These are sometimes called hybrid water heaters, which basically just means they have electric coils in there like a traditional water heater, but they try to use the heat pump as much as possible. And while those traditional outdoor, the air source heat pumps sitting outside will achieve 300% efficiency at their absolute peak when they're at the optimum temperatures outside, these will achieve that pretty much all the time. They're working in a garage, basement, a utility closet, wherever that lives, and you won't get down to the sub-zero temperatures where they can't operate. So they're incredibly effective in terms of their efficiency. They just barely outcompete natural gas in terms of their operational efficiency. And And so then on electric equipment, jump down 2 slides. Sorry, we're talking about electric thermal storage heating first up with heating. So yeah, this one is the one that is the most mature. This has been around a long time, as Dan mentioned. There's probably 30 years or so of this in the territory. And it effectively heats up a bank of bricks inside the unit that you can see sitting behind the little kid who's sitting there during our off-peak times. And then it turns its elements off and heats from the bricks, blowing a fan across them during the on-peak hours. And the timing on this scenario ensures that all of the consumption that you're pulling into your house happens at the low cost and low emissions time of day. So as you can see there, it's your chart, you're getting your heat for effectively half price because you're on time of use and the heater's only running during the middle of the day or then kind of later at night, heating up this big bank of bricks and then blowing across it to heat the rest of the house. So that's how that kind of older technology achieves similar or competitive results with heat pumps in certain scenarios. And then electric equipment was touched on, and this is something that's just growing really fast. I feel like I can barely keep up, and every time I look, there's something new on the market in terms of electric equipment. Everything from snowmobiles to electric chainsaws, which work really well and are pleasant to operate. And so I would also stress on this one that if you're in any kind of doubt, just check with us, because if it has a battery and plugs in and charges, we can almost always find an appropriate rebate using the same criteria we do for the rest of the consumption criteria we do for the other tools. And if you have a neighbor or somebody with these, I'd also say try it out, because they work really, really well. And they're kind of safe to use. You don't have the gas involved. They're less finicky, and I found them to be pretty reliable. So electric vehicles, this is a huge one for beneficial electrification. This might be the poster child of beneficial electrification. There's that scenario where most people would otherwise arrive home right around 5 o'clock or this time that we're sitting here right now and have plugged in their vehicle to charge, which is right over the top of our peak. And that's effectively piling on their new load, which is more often or can be greater than the rest of their home combined to time right on the top of the time when we're actually peaking. So by timing the charge later in the evening without making the owner worry about scheduling their car or when they plug in the cord, we can dodge that added load on our system to a time when a whole bunch of devices have already gone off. And at that same time, we provide that same half price electricity scenario via our time of use rate and a free charge point charger in this case, and up to a $500 match on wiring, which makes it a win for all parties, while the utility is still recuperating our costs by avoiding that demand charge. So those are all big benefits, I think, of electric vehicles. And as we move forward, we'll not only reduce our peaks, but we'll be able to charge opportunistically via the smart network of level 2 chargers that we're giving out here, which could allow us to soak up excess renewable production during the sun-drenched afternoons when there's basically too much energy being produced. So we can probably go on about electric vehicles for a really long time, but I will move on in the interest of time to induction cooktops. And these are a little lesser talked about probably in the media than electric vehicles, but I think they've got a lot of benefits to them, and they've got the fast heat control that is actually a lot like cooking on gas. So I think that's a lot of common complaint for people who cook on electric, is that they don't have that instant response, which induction actually has. And then they're cleaner for the air and for the inevitable messes as well. I don't know if LPEA will ever do a cook your own breakfast event. It'd be kind of cool. The other thing with the cooktop and the hot water heater and either the heat pump or the ETS I mentioned, you're basically at the point where you're at a fully electric home. And at that point, if you're doing a new construction or in any scenario, you can cut out natural gas completely. You don't have to pipe for it. You don't have to get set up for propane. You're all electric, and you have just basically one utility that you really need coming into the home. And so those are the big three, and you're basically there for that. E-bikes. This is another really popular one that's kind of growing, and I think there's a lot of kind of peripheral benefits to this as well. It really does expand access to multimodal transit and reduces emissions and congestion, which is definitely an issue for Durango itself. And also, I think it can be kind of an equity thing where it reduces the cost and burdens of commutes for core right now. along with supported by LPEA and the City of Durango and FLC, is doing an e-bike project for local low-income essential workers that work at Zia's and some of the other restaurants around here, that I think is a good example of this, to give people a way to commute cheaply and affordably and in a green way. All right, and so lastly, some of the more just high-scale benefits to the grid come back to the things we can do when we have more resources, which really for us right now means the more batteries we have communicating on our system, the more energy we can store during those highly available times. And then those devices and loads we can turn off when everything we can't control, such as people's lights, or when you use computers or watch TV, and those all come on in our absolute peak. We can take at least all these other things we can control, and then people aren't really going to notice if you've got a full car in the morning, and bring that peak way down. Our system has to support that peak at a minimum. As more and more technologies like electric vehicles are adopted, we have to accommodate them coming onto our grid. And so ultimately, we don't have direct control over when people buy electric vehicles, but we have to be ready to keep them all going when they do. And so that's kind of the negative side of, like, we pretty much have to accommodate these things. We want to do it as well. So we're trying to do this ahead of that, driving us into the scenario where we absolutely have to do this. And then I think the last part is really exciting on here, which kind of refers a little bit to vehicle to grid, which is this dispatch, which is to where we could actually use these batteries to do energy arbitrage. And so in this case, we can not only avoid that peak growth from a vehicle coming onto the grid and building on to the high point, but we can actively cut off the top by pulling energy from the vehicles back onto the grid. And that's kind of the whole next level of this, that we probably will have our first pilot going on here by the end of the year. That, I think, is pretty much wrapped up on the tech side.
And Dominic, do you mind if I interject a couple of things here?
Of course, yeah.
I just wanted to, before we go on to the Q&A section, I wanted to share some of the experiences that we've had with these various technologies. I like to practice what I preach. I've adopted a lot of these myself, and can maybe share a little bit of context with you on some of these things before we get to that. I don't have a heat pump heating system in my house, but I do have ETS heat. I've been all electric for all my life, honestly. So definitely have seen the huge amount of savings in my electric bill on the ETS side, and love that heat. But if I build a new house, I'm going to be looking at the heat pumps for sure on mini splits and what that can do. To touch real quickly on the heat pump water heaters, we do have one of those at La Plata Electric that we're using, and we invite, once we can open up our lobby and have people inside our building again, we'd love to have you come and put, eyes on this system that we have installed in there. And it's, we've done some demos with it to run it just on the heating elements versus with the heat pump itself. And honestly, the cost to run it is 1/3 with running it in the heat pump mode than it is in the traditional electric mode. And it makes the room quite cool where it sits in there. Good thing there. Don't have an electric car yet, but that's certainly on the horizon for me. I do have an electric chainsaw, electric lawnmower, and I use those all the time. I love them. The induction cooktop I just wanted to hit on real quick. Maybe the beer analogy that Dominic used, that's one thing that comes up with mine on the induction cooktop, is that in brewing beer, I find that occasionally I boil my brew over every once in a while, and the induction cooktop makes it real easy to clean up. And so I'm sure we all boil pasta over every once in a while as well, and it's definitely a wonderful device there to try out. So I just wanted to put a little bit of that context in there too, and be glad to answer any kind of questions that you might have going forward here.
All right, thank you guys. So let me just give a brief tutorial of how the Q&A is going to work. I know we went through this slides pretty quickly, but we figured there would be a lot of questions, and we really wanted to open the floor to you. Also, if you're registered for this webinar, you will be receiving in your email the slides. So you'll have these for future reference if you might have missed some of the stats on the earlier slides. So it looks like we already have a few questions in the queue. And I would invite many more on any of the things we discussed today or other questions you may have. And to do that, you have two ways of doing that. One, you can type in your question by hitting the little Q&A button at the bottom of your screen, and then we'll just read that a question aloud for you and address it here live. The other option is you can raise your hand and you can ask your question to anyone on the panel live. If you're on your computer, all you need to do is click the raise hand button, which is again below you at the bottom of the screen. If you are one of the two people calling us via telephone, just press *9. That will raise your hand, and then we'll call on you and unmute you. So let's go ahead and get started. I'm actually gonna pick a question that came via email to us. We get this question a lot. And the question is regarding heat pumps. The member asks, I did some light research on heat pumps a while back, which indicated that heat pumps were not very effective and not very efficient at our altitude and for cold weather climates. I also heard that same comment from a local HVAC contractor. So in your experience, are heat pumps effective and efficient here where we live?
Maybe I'll start off on that one and let the experts fill in behind me here. Heat pumps have matured tremendously over the last 5 years, especially. And what used to be yesterday's heat pump is definitely not today's heat pump. And we found that some of the contractors we've spoken with that are doing traditional HVAC systems are very much associating heat pumps with yesterday's heat pumps. And with the variable speed drives and the inverter-based systems that are out there now, I don't want to get into too many details on how these all work, but they've worked down to temperatures of -13, -15 degrees. They do work at altitude. We have several of these systems installed in our service territory right now. So you are by no means installing serial number one on these heat pumps. We have several of them active and out there right now. And I think that was there another part to that question, Hillary, that I missed? Okay. And certainly, I think we failed to introduce Dennis and John here earlier too. Dennis and John are our energy use experts that are here on the LPEA staff that are definitely able to answer any questions, that you come in and say, hey, what's going to be the best way for us to address our heating needs at our house? I've got this or that kind of situation, because every situation is somewhat unique, and they can definitely help you determine what is the best way to go forward on that. So I wanted to give that quick introduction and see if they had anything to add to that as well.
Yeah, definitely. We see a lot of heat pumps going in these days. We offer some really good rebates on them, which are, kind of geared towards, the tonnage. But one of the things I would stress is just a sizing that, make sure that it fits the square footage of your home. The R values are kind of tied into that. But you want to look into like the cold climate. That's kind of the key word, and the higher ratings. So they're out there. They are performing in the area. There's a lot of them going in every week. So
I would like to add something else to that. I think that we've received questions from a number of members. I'm also seeing some questions here in the chat. We often get asked if we can recommend contractors, if there are local contractors that are skilled and that we can recommend. We want to let everybody know that we are in the process of launching a qualified contractor program. We already have a qualified installer program for solar, and we're working on having a qualified contractor program for other types of technologies, such as what we're talking today. In order to become a qualified contractor and be on our list, you would have to do training with that. They would have to do training with us, meet some minimum requirements, not receive complaints from our members, and a number of other requirements. So we are working on that, and we hope that by June, we will be able to launch that program and really be able to offer our members some good lists to choose from when installing this tech. Okay, let's go to the next one. This one is from Steve Smith. What are your thoughts on using heat pumps and gas furnace backup in new construction?
Hillary, I can take this one. So I think as this technology has come along, we're finding that gas backup may not be necessary. So you have kind of two schools of thought there. One is you can use resistive electric backup or gas. But we're finding that with properly designed systems that are sized correctly, that backup is probably not necessary. So we do have to defer to a contractor to size that system correctly and give you recommendations on backup heat there. But that school of thought has changed. It's not necessary that you have to have backup heat within these systems anymore. Properly sized systems will carry the full heating load. And that is down into the negative 15 degrees is what we're seeing.
Great. Let's go to another one then. Let's see. I have a hot water baseboard heaters and an old gas boiler that runs the system. What would it look like to change that to heat pump heating? Could there be a phased transition? What kind of expenses are we looking at here?
Yeah, Hillary, I can grab this one as well. So the answer is maybe on this. It's going to depend on the system and the temperature of water that system is going to require, and whether a heat pump can actually put that temperature through those lines. So again, I think this is going to be one where you're just going to have to consult with a contractor to look at the existing system and figure out will that heat pump system actually carry in. So there are definitely some custom approaches to this to be able to retrofit that. And I like your thought here of being able to do this as a phased approach. But yeah, the answer, unfortunately, is going to be maybe on this, just depending on what that system looks like.
And if anyone else has anything to add to the initial answers, please just jump in. But looks like it looks like we're getting a lot of heat pump questions right now. So let's just stay on the heat pump train here. Let's see, can a heat pump water heater be used for radiant floor heating?
Yes, definitely. Yeah, I think we have a couple in the territory too. So you can definitely do radiant in-floor with a heat pump. Again, the limitation on heat pumps is just going to be that temperature that can actually go through those lines. So you just have to be careful how you design that system.
All right, next up is from Mark. What approach is recommended for heating and cooling a home with existing in-floor heating but no cooling? Reversible heat pump for existing system versus mini split versus other.
I'll grab another one here. So in-floor heating, you can do cooling through, but you have to be very, very careful. If you're hitting dew points within that system, within a floor, now you're starting to build moisture into that floor. So you can do in-floor heating, but honestly, I think doing something like a mini split system customized with that in-floor loop might be something to look at, so that you're doing some heating and cooling through the actual cassettes and the minis. But yeah, in-floor cooling is a possibility, but it's it's not going to be your best option. It's pretty finicky. There is some risk there. So definitely a custom approach. And again, I think that's get in touch with a contractor, have them look at the system that you have in place there to be able to judge whether you can do some sort of retrofit or you have to abandon the loop for your cooling. So yeah, that's definitely going to be a custom job there.
Hillary, you're on mute.
What, you wanna hear me? Imagine that. Let's see, this one's from Joey. Our house has in-floor heat, which uses potable water heater, which uses a potable water heater. What would you recommend as an efficient replacement?
Yeah, I can grab that one. Hey, Joey, how you doing? I've seen these custom kind of setups with like a marathon water heater running off of, for your in-floor heat with like a circulating pump. I would suggest going with like maybe something like a hybrid water heater to retrofit that. If you wanted to keep the same type of system, they're very simple. As you know, I think we've talked in the past. But the other option would be going with like a straight up just heat pump, boiler full electric system, and you can definitely have like kind of the sidearm for the for the domestic hot water added on to that too.
Great. All right. Would you be able to tell us about the benefits of a heat pump water heater versus an on-demand tankless electric water heater? Also, with the newness of integrating this technology, are there recommendations on who locally can help design and price BE systems? So we kind of discussed that latter question with our qualified contractor program, which is coming, but who wants to take the question on heat pump water heater versus on-demand tankless?
Well, I've got 2 points on it. I can talk about the efficiency and then one little nuance I know. So that the heat pump hot water heater is more efficient. You're going to get better efficiency significantly. The on-demand is still just a heat coil. It's not keeping the tank warm, so you don't have that heat loss in it. But it does have to. It still only gets closer to like 140%, maybe not the 300%. So you take a loss there. If you have not enough space for it, sometimes those work quite well. People will do that. The natural gas is more common, but the other thing to consider is if you are, I don't know where you're located, but if you have any kind of heaviness in the water at all, you have to do a really good job on taking that out, or you void the warranty on inline hot water heaters. If they find any calcification or at all, they're very prone to that, where the tanked water heaters are not. So if you're not on city water, anyway, it's one more thing to think about.
Yeah, I would say.
I
was just going to say, that the tankless, the demand, water heater is going to use a ton of energy to heat that water whenever you want. So, if you're working with a time of use program or our time of use program, you're going to want to watch the peak times. Or if you're on the standard rate with like a demand sort of charge, you're going to want to watch that. I've seen some pretty big systems out there with 90 amp breakers feeding these systems. So they definitely use quite a bit. I see a lot more kind of geared towards like natural gas, kind of that setup where they're installed, but just keep that in mind.
I'll throw a plug in here. So what Dennis is talking about is, an air source heat pump water heater, or even a traditional water heater, we can put these things on controls so that they're not heating that water during those peak periods. So you're still always going to have hot water, but it's not going to be with that water heater creating that hot water on the peak. So whether you want to switch over to air source heat pump water heater, or you're sticking with your traditional water heater, certainly reach out to us and let's talk about controls and how we can kind of shift that load off of that peak, whether you're on time of use or not. Timers are a great thing to add on to your existing, or it's something that we want to make sure that comes with that air source heat pump water heater as well. There's dollar savings to be had there for sure.
Yeah, that would be the last consideration too, is we do have a $700 rebate for the heat pump water heater. And there's an excellent Rheem $1,100 water heater. So that makes it a pretty good deal as well compared to an inline on demand.
All right, have a good one from Barb. They're building a home. They're wondering what installing a full heat pump would look like. Is it possible to use our ducting, or would there be a unit mounted on the wall in each room? How does the cost compare to combining GFA and split system heat pump?
Can I take a whack at this one first, guys, and then let you follow up? Barb, I'm looking at building a new home as well, and looking at evaluating the different options that I have ahead of me. And, I've taken into account the one option going propane, because I'm outside the city limits. Other option being a heat pump is the other option I'm looking at. And when I look at what all I can eliminate from the job of building my house when I just go with a mini split type system, and in fact going all electric, I don't even have to run, as Dominic mentioned, a gas line to my house. I don't have to have a propane tank sitting out there. I have to worry about filling up. I don't even have to have ducting in my house. These mini split system, what it looks like is that, imagine a wall-mounted compressor, or actually it's maybe sit on a concrete foundation outside the house. And for my house, I needed maybe two 2-ton systems is what that was sizing up to be. And so there would actually be 2 units, which I sort of liked because I've got some redundancy there in case one goes out, and I've got the other one there. And these units can also do multiple zones. And so one of those heat pumps might have a bedroom, a kitchen, and a living room on it, and the other one maybe has an upstairs and a couple other bedrooms on it. They can have individual zones that would you can regulate the temperatures in your house wherever you want for each room. And I mentioned not having ductwork, so with a mini split system, what you actually have is refrigerant lines that would run from that outdoor unit to indoor cassettes. And those cassettes could be a wall-mounted cassette, as Dominic showed in the picture. It could be a recessed ceiling cassette. It could be a recessed wall cassette. Lots of different ways to integrate it into a building envelope, especially if you're doing new construction. You can go ahead and allow and make room for these recessed type fittings there. There's also some hybrid systems where you've got maybe a mini split system with a small amount of ductwork. So you've got one cassette type of thing that might have a small amount of ductwork that just goes out to 2 or 3 neighboring rooms. For instance, a small bathroom that you're trying to heat as well. So that's one of the things I'm looking at. And when I compared the cost of running that heat pump to propane cost, I was saving $1,500 a year. That's a big number. And when I looked at the cost of installing each one of the various options, they were equal. For me to put in propane with the duct and the propane heating system versus a heat pump, they were pretty darn close to being equal. In fact, the heat pump came in a little bit less. And then on top of that, I get the $1,500 a year savings with the fuel. And then on top of that, normally I wouldn't install air conditioning in my house, but with a heat pump, I can run that in reverse, and I have air conditioning on those 2 or 3 or 4, sometimes 5 really hot weeks that we have in the middle of the summer that I can then have air conditioning in my house. So that's why I'm hands down going mini split heat pump on my new home construction. So hope that helps and fill in any gaps, guys.
Now, Dan, I think you nailed it, but I want to highlight what you had talked about, and that is the ability to zone. If you picture a traditional, furnace with ducting, it's pushing essentially the same pressure out to every single room in the home. And the only way that you have to control that is to open or close louvers on to registers on the vents. Where if you imagine these heat pumps have some mini cassettes recessed in the ceiling, and you might have one for your bedrooms, you might have one for a living room, you might have one for kitchens and front rooms, and you use those rooms very differently at different times of the day. And the real advantage here is that we can control those areas of the house and put them at different temperatures based on whether we're actually going to be occupying those areas during those times. So letting the bedrooms kind of cool down at night or heat them up to the temperature we want to at different times, letting that kitchen cool down at night, letting the living room cool down at night, really lets us dial in where that heat's going in our house rather than it just being thrown all over the place and us not being able to control it. And that's really where a lot of extra savings is going to come into these systems. So it's making our homes smarter and really using the technology to our advantage here.
Yeah, Barb, I was going to also mention just please take advantage of our rebates that we offer. You know, if you're building a new home, we have everything from, you know, all the lighting, all the bulbs, you know, up to 50 per year. Your Energy Star appliances, obviously the heat pump also, you know, $500 a ton on that. So just please reach out to us and we can help you out.
And that's a good segue, Dennis, into a question we got on rebates. Paul, we haven't forgotten about you. I'm going to get to your question next. But we did get a question from Lori, which is, I think, a good one. Do these rebates only count for owner-occupied homes, or can a rental property owner install them and also get the rebates?
Yeah, so it would be geared towards whoever's name that account is in a lot of times. So we do see that quite a bit. Obviously, if you own the structure and you're renting it out, it would go towards whoever that account, the LPEA account holder is. So we do, you know, we do a lot of different things working out, you know, and all we want to do is try to help out and get you guys pointed in the right direction. So.
And I would just call out to everybody, any questions you have on rebates, there've been a couple that have come up in here, just send an email to rebates@lpea.coop. It'll most likely be Dennis and John that are answering that. So if you have specific questions around the dates when things were purchased, around your specific, you know, purchase, around, you know, your specific homeownership or rentership, you know, situation, then please send a message to rebates@lpea.coop. Also, as one of our attendees pointed out, there are some great resources and guides, PDF documents that can really walk you through everything that you need to know around heat pumps. And we have those, and we'd be more than happy to share those with you. We can email them to you. All you have to do is send us an email and we'll reply.
Hillary, I noticed a few questions on backups to heat pumps. Can I fill in some stuff there?
Can we do Paul's first? Because he's been waiting for a long time.
Yep.
He's got his hand raised and he put an email in and a message in. So his question is, how do heat pumps interface with solar panel net metering when he produces peak during the day?
During the day. So I'll jump on that one there. You know, net metering and heat pumps sort of work independently of each other. You know, they both work standalone. Now, ideally, what we love to see is when your load at your house aligns with when you're producing your solar electricity. So ideally, we would love to see the load coming on during the day. Now, heat pumps are, you know, since it's naturally colder during the evenings, heat pumps are going to work a little harder in the evenings in the wintertime. But in the summertime, when we do have those air conditioning days, they do work during the day more often. But they really work independently of each other, since the way net metering works is it just spins your meter backwards and allows you to use that banked electricity at any time, honestly. But whereas with ETS heaters, that might work a little better in conjunction with solar, because that is a controlled and managed load. And so you can actually time ETS load to come on in conjunction with solar to align. So there's benefits and different benefits to each one. Heat pump's definitely going to be more efficient overall. You're going to get more bang for the buck out of each kilowatt hour you put into the system there. So hopefully that sort of covers that question there.
Yeah, and Dan, if you want to ask the other one on backup.
Sure. Yeah, I saw a couple of questions come in on, you know, how does it work with gas backup? How does it work with a variety of other different things as backup? And, you know, it used to be that every time you put a heat pump system in, you were putting in some sort of backup heat with it. I would still, you know, it's still not a bad idea to do that on the coldest. You know, they go down to -15. Very rarely does it get that cold here, but there's, like with any heating system, there's a chance that you know, something could fail along the system there somewhere. So I'm never going to say don't put backup heat in, but the majority of the heat pump systems we're seeing going in today do not have a dedicated backup heating system with them. I've seen a lot going in. I don't know if I can say majority. I'll let Dennis or John address that, but I've seen a lot going in without necessarily a backup heating element. A lot of them used to put in plenums in the duct that had electric elements that would come on to assist the heat pump if it got too cold. Now that they're getting down as, in operating temperatures well into the negative degrees, that's not necessarily something there. I mentioned putting the heat pump in at my place. I'm looking at putting in a wood stove to have there as a backup if I ever do need it there. I'll let the other guys jump in here.
Yeah, no, Dan, I think that's 100% correct. It is becoming the norm to not have backup heat. And that we actually just saw from a co-op partner, even when you had that resistive heat in there, it was seldom used and the cost was very low. So things are kind of leaning towards just that resistive heater inside the ducts. It's the low upfront cost rather than having to bring in propane and all these other fuel sources. Is just stick to electric. If it is necessary, it's there for you, and it's really not going to cost that much if the resistive electric has to turn on at any point.
Great. What is the likely lifetime of a mini split heat pump?
Dennis, I think you looked at a couple of those, right?
I was looking, they're actually comparable to a propane or a natural gas furnace. I'd say about 20 years is what they're getting out of them. I mean, it depends, like maintenance is key on a lot of things. So, some people have said, 15 years. I'd say 20 years is probably a good understanding with that. I've talked to some contractors just kind of poking around with that, that question, but what the response were, if it's over 20 years old, they really don't even really want to work on them with the propane furnaces, let's say. So that was interesting. So I would just say keep up your maintenance and that will prolong the life of your equipment.
And that segues perfectly to another question. Sorry to interrupt you, Dominic, but maybe you guys can answer this together. There's a question about what does the short and long-term maintenance on a heat pump system look like?
Yeah, I was just going to mention that it's almost identical to an air conditioner in that sense. You've got the outdoor system, and in this case, they're mostly ductless, so you don't have the ducting maintenance type stuff. You just maintain your compressor outside on the pedestal. You want to cover it up in the winter, ideally. In this case, you're probably using it in the winter, so you don't necessarily cover it up. You want to go shovel it. You want to do some basic stuff like that. And really relatively low maintenance, though. I mean, like most people's air conditioners, you don't mess with it too often. So I think it'd be
fair to say it's comparable with other technologies that are out there. I'm not seeing anything that's saying that, wildly different, that, like Dominic said, than your typical air conditioner. The heat pump has been around for a long time.
Okay. Here's a new question, not in line with what we've been answering, but a good one. Are LPEA's peak times likely to change? If there are a lot of people charging their vehicles, say from 9 to 10 p.m., might that create a new or a longer peak?
Yeah, that's a great question. And it's definitely a possibility. However, LPEA has recently acquired a new sophisticated platform to help us with those endeavors in the future. And it's we'll say a distributed energy resource platform that will help us manage different things such as electric vehicles, ETS heaters, maybe some Nest thermostats on a voluntary basis from our members, where we could maybe offer an incentive for additional control on our end and not just let things sheerly work off a timer as we have been doing a lot of in the past years. Right now, all ETS, actually we've learned to stagger our ETS heaters in, but you're right, as we send out time of use, just a blanket time of use type of pricing signal, and if everything were to come on at 9 p.m., that could certainly set a new peak for us. So we have that as one tool in addition to several other layers of control that don't involve coming on immediately at 9 o'clock. Maybe we have some coming on at 9, some at 10, some at 11, staggering that across to avoid exactly what you're talking about there. There's always a possibility that we could have to make some minor tweaks to our time of use hours. We've done it in the past. We'll probably have to do it in the future some, but there will always be a need for our members to help us with controlling that load, and we want to share an appropriate pricing signal for that.
All right. Martin also shared that FYI ductless mini splits have indoor air filters that also need to be cleaned as part of maintenance. So that was just a comment. So thank you for the reminder on that, Martin. And Martin also has another one that is way above my head. Jan, I'm guessing this one's going to you. Are there any solutions for the problem arising with the change in electrical code now requiring GFIC breakers that are not compatible with inverter-based equipment? So
Yes.
maybe you can translate that one for those of us who aren't.
Sure.
and then answer it. That would be awesome.
I'll give it my best shot. Yeah, basically a GFCI breaker is a safety device, so to speak, that allows a breaker to trip not just on current overload, but anytime it senses a flow of power on the neutral, on the ground wire there. So it's a really sensitive, very fast reacting kind of element. It makes a house very safe. But with inverter-based technologies that only take, part of our sine wave that we send in, that can cause neutral current to occur, which then can trip those breakers. And so there's definitely some things to work through there. And I'd be curious if Dennis or John have had any experience with that, but I know that was something that one of the installers told me to keep an eye open for. And he had a workaround for it, but I can't remember what it was off the top of my head. But so, Dennis, John, do you have experience with that?
Yeah, that if it's a piece of equipment and a dedicated circuit, you can kind of get around not having that GFI, the GFI breaker on it. A lot of times they have a breaker lockout also, but it takes like if you were going to put, like, let's just say a freezer in your garage, a lot of that time it's GFI protected. But if it's just one single dedicated receptacle, there was actually in the code that you can get around that. So a lot of the bigger equipment, let's just say a heat pump or any of the appliances in the house, they wouldn't be GFI required. The arc fault is kind of different too. Obviously, that's the path from the neutral. But that would be just for general receptacles and things like that. So I think you can get around that, with that dedicated circuit possibly.
We have another question that was submitted via email. It's slightly duplicative, but I think worth repeating. Please discuss the pros and cons of all electric versus a current home being heated by propane with underfloor heating. Do we know what the cost to convert to water heated by electric would be?
One thing that comes to mind that's often overlooked is air quality within a house as well. I can't tell you how many times we've had energy efficiency inspections that also look for natural gas leaks and propane leaks that turn up, poor ventilation, those kind of things. So I'll say air quality and safety is one thing that oftentimes slips off people's radar. I think I did hit on a lot of the aspects, like with our home, not having to put in ducting, propane venting, the propane lines themselves, having an ugly propane tank sitting in front of my house. Those are the things that led me that direction. And I'll probably stop there and let others add to that if they've got anything else to add to that.
Yeah, no, I think that's it. It's air quality and safety, certainly. And then, yeah, controllability here going into the future, I think is going to increase with electric. Like we talked about, being able to zone things off before. As far as cost goes, yeah, you're going to get a huge range here. Unfortunately, I can't give you a great number on this, only because it's going to depend on the size of the house, the existing system. But if I had to throw a number at it, your starting point is probably in the $4,000 or $5,000 range for a retrofit like that.
Yeah. And, you know, I also want to touch on since we are doing an Earth Day presentation here, to touch on the carbon aspects of it all too. When comparing the electric grid, even as it sits today, to propane and natural gas, they're fairly comparable in those respects there. Now, once the grid is getting greener and greener, then electricity definitely wins out on the carbon footprint. And also we have to consider efficiency. When you talk about a heat pump, you're talking about, you know, I know it sounds crazy, but they're talking about 300% efficient devices, you know, because of the expansion and contraction cycle that it's going through. For every unit of energy you're putting into it, you're actually getting 3 units of energy out of it. Whereas with any kind of natural gas or propane type system, it is unit for unit. In fact, it's a little less. You put 1 unit in, and then you have to consider the efficiency of that gas unit. So you might be putting 1 unit in and getting, you know, maybe something that's 85 to 90% efficient at best, you know, back out of it. So after you add that efficiency rating in there on top of it, carbon footprint with heat pumps is absolutely a clear winner, and only going to get better as our grid becomes greener and greener.
Great. All right, so we did have several questions that were about solar. We're not going to have time to address those today. We're almost to the end of our hour, but I will remind everybody that we will be doing subsequent webinars throughout the rest of this year and doing deep dives into specific tech. So please stay tuned for those. Also, just a reminder, if you feel like your question wasn't answered, you can either call our main line and ask to speak to one of our energy management advisors, or you can email rebates@lpea.coop. There's also more information on our website at lpea.coop/rebates. And I guess there's just one final comment here from Richard. Thanks to Dan for talking about the health effects of gas in the home. Homes with natural gas cooking stove increase the chances of childhood asthma. So just adding that health factor to that. I think we're done for the day. We're going to finish right on time and let everybody get back to their evening. I will be following this up with an email with links to the slides and a link to the presentation, the video, if you'd like to watch it again. We'll also put more information in there about the URLs and the email addresses that I just shared with you all verbally. But I really want to thank you guys again for being engaged with us. We got more than 30 questions from everyone. We'll continue to offer more of these in the future. And just remember that we are here as a resource. If you have any questions, want to explore something more, please just give us a call or send us an email. And with that, I'll bid you adieu for the evening. Thank you, everyone.
Thanks, everybody.
Thank you.